Hi everyone, and welcome to the video for Friday, September 6th. Um, this video introduces one of the concepts that is at the heart of computer science. In this course, we're going to do two foundational concepts. Computer science cannot run without these concepts, and one of the concepts is an if statement, and the other concept is a loop. So we're going to do if statements now, and we're going to get to loops next week. And both of these concepts are incredibly powerful, and it's really hard to see their power without doing more advanced programs. So particularly when we get to your group project, which I'm going to assign probably on Monday, sometime next week, your group project will have if statements and loops all over the place. It's just impossible to write sophisticated programs without a way of dealing with if-then kind of thoughts. So before we get into that, though, I just wanted to briefly mention that I've used this a few times before, but I guess I've never officially pointed it out. If you want to add comments to your code, you can. So a comment is just a line of code that the computer doesn't see. The computer just skips right over it. So just use a \\/ for a single line of code you want to comment, or this \* and then * for if you want to comment out this entire code segment. So here it is. So, suppose that my program contains this, but for whatever reason I don't want it to show up right now, I can \\/ and, or // I guess. I guess it's not a backslash. So you // and then that line is gone. So now if I run this program, it doesn't do anything, right? The computer doesn't see that anymore. And by the same token, if I have these two lines of code and I want to comment all of that out, I can do like this. So /* and then */ will close that, and it'll comment out that entire segment. So at this point, you probably don't need to use this very much, but it is incredibly useful later, especially when you're debugging your code, trying to find an error in your code. If you have a really long program and you're trying to figure out where an error is, the best thing to do is comment out different parts of the code and see what will run and what won't. So that's one use. And also, if you're writing code for other people to view, which you are, it's helpful to comment it so other people know what you're trying to do. So anyway, keep that in mind when you're writing code. You can comment stuff out. Okay, so on to if statements. So suppose that you're writing a program that's going to play games with people. It seems like the reasonable way for the program to start is to ask them what game do you want to play and then get their response, right? So maybe your program will let the user play hangman or blackjack or poker. So you've written a program that will play those three games with the user. Well, what code happens next depends on what the user's input, right? If they told you they want to play hangman, then you should enter a certain chunk of code, right? If they told you something else like blackjack, you should enter some other chunk of code and run the blackjack code. And if they told you poker, you should do some other chunk of code, right? So basically your program consists of three different chunks of code, and the chunk that you decide to run depends on what the user said. So these are conditional things, right? If this, then do this. If this, then do this other thing. So what if statements allow you to do, it allows you to have the program branch into different directions based on certain conditions. So the program will enter a certain branch if and only if some prior condition has been met. That's the idea of an if statement. If this happens, then do this chunk of code. Otherwise, don't do this chunk of code. So before I show you the exact syntax of that, we need a brief definition, and we need the idea of a Boolean statement. So simply put, a Boolean statement is simply a statement that is either true or false. So consider these two statements here, x is less than 2. So if x has a value of 1, then the statement is true. But if x has a value of 5, then the statement is not true. Right? So depending on the value of x, the statement is either true or false. But the point is that it can take on a truth or falsehood value. And then just an English sentence like this is a Boolean statement. This statement is either true or false, and in this case it happens to be true. Some examples of things that are not Boolean statements, the statement hello, that is neither true nor false. It doesn't make sense to put a truth value on it. Just the statement X has neither a truth nor false value, right? Suppose that we're speaking and I just say 2. That is neither a true nor false statement, right? If I say something like 2 is less than 3, now that's true, right? Or 2 is less than -5, that's false now, right? It's actually a statement that can be true or false. So most importantly for this section, instructions are statements that are neither true nor false. If I say, write your program on the board, right? I give you an instruction. That's not a statement that has a truth value, right? The statement, you did that on the board, or you followed my instruction, that kind of statement does have a truth value, right? Depends on what you did. But if I just say, write this or do this, mow the lawn, whatever, that's not a statement that has a truth value. Okay, so if statements run on Boolean statements. So if you try to run an if statement on a non-Boolean statement, essentially the program won't know what to do because it can't evaluate the truth value of what you handed it. If you hand it the statement hello, it says, well, I mean, I don't know if this is true or false, so what do you want me to do? Will be the program's reaction. So here's the syntax of an if statement. You write if, and then in parentheses you put the statement that you want it to test, and then you put the code in there that you want it to run, and then you close it with a brace. And what's important to note about this brace is that there's no semicolon after it. Okay, so if statements don't end with a semicolon, unlike previous things that we've done. Okay, so if you see something like this inside of a program, what happens is, once the program reaches this if statement, it decides whether or not the statement in the parentheses is true or false. If the statement in here is true, then the program goes into the braces and does whatever code you've written here. If this statement is not true, then the program just entirely skips over this if statement. So it just blows right past it. So again, thinking about the game program, if the statement here says something like, the user entered hangman, right? That's the statement. User entered hangman. That statement is either true or false, and the truth value depends on what the user entered. So if the user did indeed enter hangman, then you would enter this block of code here. But if the user did not enter hangman, if they entered poker or something, then now the statement here would be false, and the computer would just skip right over the hangman portion of the code. So that's the basic setup of an if statement. So here you go. Consider this segment of code here. Int x equals 2. If x is smaller than 3, then do what's inside of here. Well, 2 is smaller than 3, right? When the computer gets to this line here, the value of x is 2. 2 is smaller than 3. This is a true statement. Therefore, the computer goes into the if statement, goes into this code here, and it does whatever is written here. So it will print what up to the screen. So by contrast, in this code segment here, int x equals 4, now when the computer gets to this statement, x smaller than 3, 4 smaller than 3 is a false statement, right? 4 is not smaller than 3. So because this statement here is false, the computer would just skip over what's inside the braces. So this code segment here doesn't print anything. Okay, so concretely, that's how an if statement works. Okay, so sometimes you'll see in a program an if statement without braces. So the braces tell the computer what to do if you're going to enter the if statements. If you don't include braces, there are sort of implied braces. And there are implied braces around the first line following the if statement. So just consider this segment of code here. X is less than 2. If x is smaller than 1, print cout high and print cout class, right? So 2 is not smaller than 1, right? Everybody agrees with that. So what the computer does is here, since there are no braces, it just takes this statement here, the cout high, as being inside the braces, but nothing else. So since this is the first line after the if statement, it takes this as being inside the if statement. And so since the statement here, x smaller than 1, since that is false, it skips over the cout high, and now it's done with the if statement. Right, the braces are now over. The implied braces are over. And now it will print out cout class. It will print the class to the screen because it doesn't consider the second line as being part of the if statement anymore. So again, you don't have to use braces, but if you don't, you're assuming that only the first line after the if is part of the if statement. Okay. So if statements can be paired with other statements. Rutrow. Okay, so we'll get to that in a second. That's a mistake here, but so in English, a lot of times you want to tell the program, look, if this happens, then do this. Otherwise, do that. Right? So if the user enters hangman, play hangman. Otherwise, do something else. So the way you do that is with an if-else statement. And what happens is you have this Boolean statement inside the if. And by the way, this should say x bigger than 0, x greater than 0. I don't know why it's showing an upside down question mark. That makes no sense. But anyway, x bigger than 0 right here. So what happens here in this block of code, the user enters a number. If that number is positive, then this statement runs here. Right? The computer goes into the if statement. If the number is not positive, so if this statement here is false, then you enter the otherwise statement or the else statement, and it will run this block of code. So if the user enters the number -5, what am I saying here? Yeah, so greater than 0, right? So if the user enters the number -5, -5 is not bigger than 0, so you go into this else statement. So sorry, this should be a greater than right here. I don't know why it's messing up like that. Okay, so let me now show you an example with temperature. Make sure I'm not messing anything up. Okay, so here's an example with temperature. So what we're going to do is we're going to ask the user what the temperature is and then tell them what a good choice of clothing is for that temperature. So let's just ask them, what is the temperature outside, right? And I guess since we have physics people in here, I don't know if you people use Celsius or not. I've been yelled at before by physics people for using wrong units. So let's just go with Fahrenheit and assume that it's correct. Okay, so we'll get the temperature from them. And now let's say something like this. If the response is, let's say, bigger than 70, right? So 70 degrees is a nice stopping point. We'll tell them shorts and t-shirt, is appropriate or something. And otherwise, we'll tell them, wear a jacket, whatever, right? So if I now run this, what's the temperature outside in Fahrenheit? Well, 80 degrees. Okay, shorts and t-shirt is appropriate, it says, right? What's the temperature outside? 55. Wear a jacket, right? See how that works? So based on the response I gave, it either executes what's in the if or what's in the else. So if this is true, then run this. Otherwise, run this. Okay, so I want to make sure I explain this properly here. So ifs can also be paired with other statements that are called else if. So imagine you want to write a program that does this, and we will write this in a second, but imagine you want to write a program that deals with multiple levels of temperature. So if it's more than 70 degrees outside, you don't really need to say much, right? Just shorts and t-shirt. But this else statement I wrote down here is kind of not informative, right? Because if the temperature is less than 70, well, 65 is less than 70, right? And so when it's 65 degrees outside, I guess maybe you need a jacket, but you don't need a coat and gloves, right? But the temperature could also be -40 degrees, right? And in a situation like that, you should probably wear more than a jacket, right? So what if you wanted to write a program that dealt with these multiple levels of temperature, right? There's like warm, and then not quite as warm, but still okay, and then cool, and then really cold. right? For example, the way you would write code that does that is with what are called else-if statements. So let's now keep my same wear jacket command. Okay, so what's going to happen right here is after the user enters their response, the computer first checks to see if this condition is true, if that temperature is over 70. If it is, then it outputs this. Okay, and then it skips past this else statement here. If the response is not bigger than 70, then it checks this statement here and asks, well, is it bigger than 50? And if so, it'll go into this. And we can keep adding these conditions here. So, oops, sorry, parentheses. Greater than like, negative 10 or something. We'll tell them to wear a heavy coat. And otherwise, if none of those are true, that means it's really cold. So we'll tell them stay inside. Okay, so before I run this, let's talk through the logic of what I just did. There are several different conditions it's going to check as it marches down through the code. The user enters a number. The first thing the computer does is ask, is that number bigger than 70? If so, it will output this statement, and then it will skip past all the otherwise statements. Okay, so there are like 3 otherwise statements here. Otherwise if, do this. Otherwise if, do this. Otherwise do this. Okay. So if the if one is true, it'll output this and then skip all the other blocks. It doesn't, this else, you really should read it as otherwise. So these are all mutually exclusive things. It will not do multiple blocks of code here. Okay, so if the response is bigger than 70, it'll output this line. If the response is not bigger than 70, then it just goes down. The computer just reads downward from top to bottom. Now it asks, well, is that temperature bigger than 50? If it is, it outputs wear jacket. If it's not bigger than 50, if it is bigger than 50, it outputs this, and again, it just skips past the remaining statements. It will not do multiple of these statements. So if the temperature is like 60 degrees, this does not run because 60 is smaller than 70. But then this will run, and then it'll skip past the other statements. If the response is 50 or smaller, it'll now move on and ask, okay, is the response bigger than negative 10? And if it is, it will output this, wear a heavy coat. If the response is negative 10 or smaller, it will move on to the very last statement, else do this, otherwise do this. So let's just make sure this works the way I said it did. What's the temperature? 65. Wear a jacket. Okay, that's what we thought would happen. What's the temperature? 40. Okay, so when I enter 40, this response bigger than 70 is false, so it should skip that. Response bigger than 50 is false. It should skip that. But 40 is bigger than negative 10, so it should not skip that. Wear a heavy coat. Okay. And then lastly, if I enter like negative 200, it says stay inside, right? Okay, so that's how this works. You can have an if followed by an otherwise if, otherwise if, otherwise. You can have as many of these else ifs if you want to, and the computer will just keep moving down until it finds a condition that's true, and then it will do exactly what's in that block, and then nothing else. So one of the pieces of confusion that I found last time I taught this course, when I have a setup like this, so let me run this again. Think about the number 65. 65 is bigger than 50, right? 65 is also bigger than negative 10. So why doesn't it run both, right? Why doesn't it run both lines of code? Both of these things are now true. Response is bigger than 50, response is bigger than negative 10. Both true, okay? And the reason is because what I just said. The computer just linearly reads downward, right? And the first condition it finds that makes it true, it does what's in that block, but then it skips down to the end. It just glosses right over these. It's only going to execute one block of these things. So when I enter 65, it doesn't go into this wear a heavy coat block here. Okay. So now back to my screen here. So that's the temperature example. You can do an if followed by an otherwise if followed by an otherwise if, as many of those as you want to. Okay, so in the examples I've done, I use greater than and less than as my only symbols. If you want to think about greater than or equal to, there's no greater than or equal to button on your keyboard. So you have to write this just greater than equal to. That's how you tell a computer to do that. Less than or equal to. Equals is like this, two equal signs. So if you're going to have an equals inside of an if statement, that's how you write it. And then exclamation point equals means does not equal. So if you want to translate these English things on the right, greater than, should say here. If you want to take these things on the right and translate them into the computer language, these are the symbols you use. Okay, so one common error that I see a lot is that people aren't used to this double equals. So the double equals is a Boolean equal. So when the computer sees this, x equals 2, the computer is going to ask itself, is x equal to 2? So like the extra equal sign almost turns it into a question mark that the computer will check whether it's true or false, right? Does x equals 2 is what the computer will ask when it gets to this line. X equals 2 with just a single equal sign is now not a Boolean statement. It's actually an instruction. Okay, remember, instructions are not Boolean statements. This statement here is neither true nor false. What it says literally in English is take the value of 2 and assign it to x. Okay, that's an order. It's an instruction. It's not a Boolean statement. So if this appears in your code, you might think that what the computer is doing is checking whether or not x equals 2, but it's not. It's just going to take 2, put it in for x, so assign x the value of 2, and then it's just going to run the if block no matter what. Okay, so be careful. When you have an equal sign inside of an if, you want to double equals. So let's just see how that plays out. Okay. So again, let's say that you're writing a game program and you ask the user, what game do you want to play? And you're only expecting a one-word answer, so you can just do cin and not getLine if you want to. Okay, so what you might be tempted to write is something like this. If response equals, and you have to use quotes here because you're talking about a string here. So if response is blackjack, then, whatever you want it to do. Let's play blackjack, right? If response is hangman, then let's play hangman. Oh, sorry, else if. Right? It actually doesn't matter. The logic is the same here. Okay, so otherwise, we're just assuming there's only one other option, and the other option is poker or whatever it was. Okay, so let's run this and see what it does. Using the result of an assignment. Yeah, it looks like it won't even let me run this. Yeah, okay, well, the last time I did this, it let me at least run it. But what it's telling you essentially is, look, you need a double equals there. Okay, so I don't know if Visual Studio does this, but before it actually would let me run it. So I'm not sure why it's not letting me run. But let's run it now and see that it works the way we want it to. So what game do you want to play? Blackjack. That's what I want. Let's play blackjack, right? What game do you want to play? Well, poker. Okay, so let's play poker. Okay, so that's the logic of these things. These things take getting used to, like pretty much anything in this course, right? You're not going to be comfortable with them until you use them several times. So one thing you might want to ask yourself is, what if the code is going to stay the same? What if the user messes up and they think that this program is going to play chess with them? Based solely on the code that I've written here, what do you think will happen? Okay. To answer a question like that, remember the computer just reads downward, right? So it takes this response in, and then it will ask, did that response equal the word blackjack? If so, then it will output this. Otherwise, if the response equals hangman, it will output this. Otherwise, it will output poker, right? So based on all that, let me hit enter and see what it does. Okay, it outputted poker. The reason is because that response wasn't blackjack. It also wasn't hangman. And when you say else, you're telling it no matter what else happened, output poker. So I could have typed in here, whatever, gibberish. It's going to output poker, right? It skips past this first block because that gibberish wasn't blackjack. Otherwise, if hangman, right, that was false, skips past it. And now otherwise do this, right? So if you want to avoid that kind of thing, you have to add an else if and say, poker, oops, response equals to. See, now the logic has changed here. Now, if I enter that same gibberish, it doesn't do anything, right? It asks itself, is that gibberish equal to blackjack? No. Is that gibberish equal to hangman? No. Is that gibberish equal to poker? No. And so now it just skips past all that. Now it's done. Okay. So the last thing I want to show you is, again, this kind of thing takes getting used to. So you just have to do this on your own to get comfortable with this. But I'm going to give you a code segment and just ask yourself, what will happen here? Like, what will the code output? So let me just add a few things. Okay, so if it's bigger than or equal to 1, output high. If it's bigger than or equal to 0, or sorry, just bigger than 0, output, I don't know, the number 10. Else if x is bigger than 1, output the number 15, whatever, right? Okay, so here's a bunch of code that has an if statement, and an else if statement. So before I run this, you should ask yourself, what would this thing output? What do you guess the output is here? And so just like always, to answer that question, just imagine reading downward, right? If x is bigger than or equal to 1, well, 2 is bigger than or equal to 1, right? So it's going to output this high. Now it gets here. If 2 is bigger than 0, output 10. Otherwise, if 2 is bigger than 1, output 15. So what happens here? It outputted the high and it outputted the 10, right? So the reason is that this if statement, you didn't include any else's or else ifs after it. So once you run this, the program is just done with that if statement. It's not checking anything else. Now the program gets to a new if statement, and now the logic of what we just did kicks in. It will either execute this block of code or this block of code or no block of code, depending, right? But it's not going to do both. Even though 2 is bigger than 0 and 2 is bigger than 1, it's not going to output both segments of code. Okay, so we're done here with this video. We're not done with if statements. There's still more to show you. But again, this code, just like anything else, you just have to do numerous times to get comfortable with, and that's what we'll do in class.